Okay, let's take a look at the problem sets from lesson 11 and lesson 12 in module 2. These lessons are all about multiplying and dividing signed numbers. Remembering what happens when I multiply a positive number times a positive number, or a negative number times a negative number, or a positive times a negative, and vice versa. There's this little diagram thing that you can draw if it helps you. It's a triangle with negative signs on the two bottom vertices and a positive sign or a plus sign on the top vertice. And the way you use it is, if you ever forget what happens when you multiply different sign numbers, you take one finger or two fingers, whatever, and cover up the two signs that you're multiplying. And the one that you can still see, that should be the sign of your answer. So for example, if you're multiplying a negative times a positive, you'd cover up a minus and a plus sign, and you still have a minus sign showing, so you know your answer should be negative. If you're multiplying two negative numbers, then you'd cover up the two negative signs, and you see that the positive sign's still left, so you know that your answer should be positive. All of these multiplications here are pretty simple, so I'm not going to do all of them for you. I'm just going to tell you that the main point of doing all these simple multiplications over and over again is to get really fluent, which is a math teacher way of saying getting really used to or being really good at knowing what the sign, positive or negative, of the product of two numbers will be. And 2 times 3 is 6, obviously. I mean, I think most people are pretty good at that. What I care about is that you can quickly do 1 times 3, but one of them's negative, negative times a positive, my answer is negative. Negative 2 times 3, okay, 2 times 3 is 6, but one's negative, one's positive, so my answer will be negative. 3 times 3 is 9, but since one of the numbers I'm multiplying is negative and one is positive, that means my product or my result will be negative. Do we have any negative times negatives in here? Yeah, so over here and over here. A negative 2 times a negative 1, well, 2 times 1 is 2. And then when I multiply a negative by a negative, well, that's a positive. So I'll just leave my answer as positive 2. Okay, so you can go through these relatively quickly, just remembering what sign your answer should be. Please be careful as you go through it. Number 2 says, explain why negative 4 times negative 5 equals 20. You know what? We spent pretty much an entire class period talking about why a negative number times a negative number is a positive number. You could re-summarize any of those 3 ways of thinking about why a negative times a negative is a positive as your answer to that. And so because of that, I'm not going to do that for you. Number 3 says, each time that Samantha rides the commuter train, she spends $4 for her fare. Write an integer that represents the change in Samantha's money from riding the commuter train to and from work for 13 days. Okay, so when she rides the train, the change in her money is negative $4. So remember, change can be directional, positive or negative. And then if she's doing this for 13 days, then I think it makes sense to multiply that by 13. But it also says that she pays $4 each time she rides, and she's going to and from work for 13 days. So that means she's got to ride twice per day. So it's going to be $2 each time. It's an expensive train. Oh, no, I guess about the same as BART. I don't know. So we need to do negative 4 times 13 times 2. I guess I'll just work left to right. I don't see any big advantage in doing it any specific way on this one. Actually, no. Maybe it'd be easier if we did the 13 times the 2 first. Let's do negative 4 times 2 times 13 is 26. The reason I see that might be a little bit easier is because I notice that 2 times 13 is 26, and I know that 4 times 25 is super easy. We know that 4 quarters make 100, so 4 times 25 is 100. And 26 is really close to 25, and so that makes this last multiplication really easy. I'll think of it as 4 times 25, which would be 100, but then I have one additional 4 because I'm actually multiplying by 26. So I know the answer is 104. And then I look at the signs of my two numbers that I'm multiplying here. One is negative, one is positive, and so my answer is negative. So basically the change in her money over a 13-day period is negative $104, or she spends $104. Number 4 says write a real world problem that can be modeled by 4 times negative 7. So that's we could basically do the same thing as just in the previous question. Okay, well, I'll even use this girl's name, Samantha. Samantha pays $7 every day for, I don't know, coffee. She's one of those people that spends a ridiculous amount of money on fancy Starbucks or whatever. I'll even write it the way they wrote it in the previous question. Write an integer that represents, I'm just using the language that they used in the previous question, the change in her money when she buys coffee for 4 days. So she'd be losing $7 each day. That'd be negative 7. And we're going to multiply that by 4 because it's for 4 days. And just for fun, it doesn't tell us we have to do that, but that's going to equal negative 28. Okay, number 5 is a challenge problem. You don't necessarily have to do it. I probably told you it was optional. And it's very similar to the third way out of the 3 ways that I showed you to think about the fact that a negative times a negative is a positive. And so if you can remember that proof that I showed you on the board, you can almost kind of sort of just recreate it, except using a instead of 1, basically. Okay, it's going to have to do with the distributive property. That's the hint that I will give you. Okay, let's move on to the lesson 12 problem set. And so this lesson was more about division, and division essentially follows the same rules. Negative divided by a positive is a negative. A positive divided by a positive is obviously a positive. A negative divided by a negative is a positive, and yeah, that pretty much covers all the bases as long as you mix one of those around. One thing to note up here is we've kind of talked about this a couple times in class. I'm going to write this bigger to make sure you can see it really easily on the screen. When you're writing a fraction, I'm going to use numbers instead of P's and Q's like they have here in the book. There's 3 equivalent ways to write the same number. If you write your negative sign pretty much even with the fraction bar, then what you're saying is this is the negative version or opposite of positive 1/2. And so you have the negative 1/2. That's equivalent to putting the negative sign up here by the 1. Because what this says is negative 1 divided by 2. Well, 1 divided by 2 is 1/2. And if you have a negative number divided by a positive number, the result is negative. And so this represents the same number as this. And you can also represent that same number as 1 divided by negative 2, because 1 divided by 2 is 1/2. And when you divide a positive number by a negative number, the whole result is negative. So all 3 of these ways are the same. Most people write it like this, with the negative sign equal or level with the fraction bar. So a lot of people also like to write it with the negative sign on top. Almost no one ever writes it this way unless there's some reason you might do it that makes solving something you're trying to do more simple. But this is sort of a strange way or unusual or infrequent way of writing it. Okay, so, but you should know that what is not the same, so I'll write an equal with a slash mark through it, is if you were to put negative signs on the top and the bottom. Because now you have a negative number divided by a negative number, and that's actually positive. So this situation would actually equal positive 1/2. All right, so just keep that in mind. I'll do some of these over here for you. Negative 48 divided by negative 4, that's just 48 divided by 4, which is 12. But then since we have a negative divided by a negative, the result is positive. I should say the quotient or the dividend is positive. The numbers, so wait, let me make sure I'm getting this just right. The number that is being divided is referred to as the dividend. The number that is doing the dividing is the divisor, and the resultant number is called the quotient. So our quotient is positive in this case. And just below it, we have negative 48 divided by 4. So our dividend is negative, and our divisor is positive. So that will result in a negative quotient, negative 12. Same thing here. Positive divided by a negative is a negative 12. And so I'll do the top one. That one was positive divided by positive, so you get positive 12. So this is just an exercise in looking at the 4 possible results when you divide all the different possible combinations of positive and negative 48 and 4. They're all going to have an absolute value of 12, but 2 of them are positive, 2 of them are negative. I think in order to answer questions 2 and 3 and 4, I have to have all the results for all these answers here. So I guess I'll just do them real quick. 24 divided by 4 is 6. So all of these are going to be 6. It's just deciding whether they're positive or negative. So this one's a negative divided by a negative, so it's positive. Negative divided by positive, negative. And positive divided by negative, so the quotient is negative. Okay, this is 63 divided by 7. These will all turn out to be numbers with the absolute value of 9. But it's just determining whether or not they're positive or negative. So positive divided by positive is positive. Negative divided by negative is positive. Negative divided by positive, negative. And this last one is also negative. So kind of looks like they're doing this pattern of 2 positives, 2 negatives, 2 positives, 2 negatives, 2 positives, 2 negatives. And I can see that that's going to be the same case here because I have positive divided by positive, and I have negative divided by negative. Those are both positive quotients. And so I can look here and see that, one positive, one negative, one positive, one negative. These will both turn out negative. All right, so now let's look at some of these questions. It says, describe the pattern you see in each column's answers in problem 1, relating it to the problem's divisors and dividends. So that's basically what I was just saying. It's, you get 2 positive quotients and then you get 2 negative quotients because the top 2, the dividend and the divisor, have the same sign. That's a real easy way of saying it. These are both positive, these are both negative, and anytime they both have the same sign, the result is positive. And then the bottom 2 in each column, they have opposite signs. One's positive, one's negative, and those always result in negative. So I know that was a lot of words, and that's really hard to sort of summarize in this small space, but the best you can summarizing what I'm talking about in that small space will work. Number 3, describe the pattern you see between the answers for column A and B in problem 1. So the answer's here and the answer's here. Well, I see that these are all half of these, and that comes from the fact that the dividend, the number that's being divided in column B, is half that of the number being divided in column A. So the resultant quotient is going to be half. Because the divisor in both columns is the same. So when you half the dividend, but the divisor remains the same, then your quotient will be half that of this quotient. All right. Yeah. Good luck summarizing all that in these little spaces they give you. I hate how much little space they give you. But then they give you this giant space for 4. If you want to do something like write for 2 and 3 down here in this space and make it clear what you're doing, that's okay. 4, describe the pattern you see between the answers for column C and column D in part 1. So, you know what, it's literally the same thing, except for the relationship's slightly different. So I'm gonna let you see it for yourself and write your own answer. All right, that's it.